Hello there. So today I'm going to go over lessons tasks 1, 2, and 3, or try to get to 1, 2, and 3 for linear algebra. This is for myself to help study and help to teach myself, and this is to help me be able to come back to it and, well, essentially learn this in a better way. I'm not doing great in my studies. No matter what I do, it just doesn't seem to be sticking at this moment, or my courses don't seem to be, my tests don't seem to be reflecting this, unfortunately. And so, I need to come up with different methods to improve. So today, I've decided to try and do this, where I record myself going through questions. So, again, for lesson 1, task 1 for linear algebra, we're going to go through each of these questions. These are, there's back substitution, so solving back substitutions, determining solutions through graphing, and solving equations, essentially, through linear algebra. So, we're going to start off with question 1, and it's A, which is this one right here. Okay. So, this is an easy back substitution. This is x1 minus 3x. Oh, 1 second, I forgot to put a number at the end of that. Which is easy to fix, though. 2. Okay. Huh. Anyways, so this is fairly simple. All you have to do is you have to figure out what are the solutions for each. Well, right now we have 2x squared equaling 6. This is actually really easy. We go divide by 2 to get x2 equaling 3, and then we back substitute into it. And what that will give us is x1 minus 3 to the 3 equaling 2. x1 minus 9 equaling 2. And then we add 9 to both sides, which is going to give us x1 equaling 11. So for this, it's x2 equaling 3 and x1 equaling 11. And those are the solutions for that. Easy peasy. C is a little bit bigger, but it's the same principle. We get x1 plus 2x2 plus 2x3 plus x4 equaling 5. 3x2 plus x3 minus 2x4 equaling 1. Negative x3 plus 2x4 equaling negative 1. Now this is a little bit more difficult because there's 4 variables and 3 solutions. So that means either one of them is zeroed out, or one acts as parameter, which means that it has an infinite amount of solutions when you have it equaling that. So first we're going to start off with the easiest one, which is this one right here. And the reason it's the easiest one is because it's the least amount of variables. So what I'm going to do is I'm going to go x3 divide by negative 1. The reason I'm dividing by negative 1 all across is so that to get rid of that negative in front. So now I got x3 minus 2x4 plus 1, because a negative divided by negative is positive, right? And then I'm going to bring this to this side by adding 2x4 to both sides. Again, I'm just showing the steps here, but what essentially happens is these two will cancel out, giving you 0, and you'll get x3 equaling 1 plus 2x4. Okay? And that's a really good solution for x3, and now we have to bring it back. And so now that we have something for x3, we bring it back into the very next one, which is this one right here. So we get 3x2 plus 1 plus 2x4 minus 2x4 equaling 1. Since it's a positive in front, we multiply in. You have to multiply in no matter what, but the reason that it's going to give you, well, these is because 1 times 1 is 1, and 1 times 2x4 is 2. This would be a little bit different if there's a coefficient in front, like 3 or 4, or if it was negative, but you can just keep it. So 3x2 plus 1 plus 2x4 minus 2x4 equaling 1. These will cancel out, giving you 3x2 plus 1 equaling 1. Now, if you have 1 and 1 on both sides, essentially what that means is that 1 plus, or you minus 1 to get rid of it on both sides, and what that means is you're going to get 3x2 equaling 0. Well, 3x2 equaling 0. And essentially, what that is going to say is that x2 is equal to 0. Which makes things a lot easier, because now, when we come back here to these three equations, we know that x2 is 0, so you can cancel that out for both of those. So there was a 0. There was no parameter, which is nice, because you don't know what parameters are at least not in the very beginning. So we get rid of it. We then have to the very top equation right here that we had to deal with, where the 2x2 is zeroed out, but I'm going to write out the full thing quickly, just so that you can see it, plus x4 equaling 5. Now, we know 2x2 is zeroed out, so we don't need it. We still have to solve for x1 and essentially x4. So x1 is going to equal, x1 plus what is in 2x3, which was this line here, is going to go in. So there is a coefficient out in front this time, so we get 1 plus 2x4 plus x4 equaling 5. Okay, so you multiply the coefficient out, which is going to give you 2 plus 4x4 plus x4 equaling 5. And then these two have the same variable, so you can add them together. So you get x1 plus 5x4 plus 2 equaling 5. We're going to subtract 2 on both sides to get 2 on this side, because we want everything on the one. We want everything on the other side. So we'll end up with x1 plus 5x4 equaling 3, and then again we're going to subtract to get one side, x1 plus x1 equaling 3 minus 5x4. Okay, so as of right now we have x1 equaling 3 minus 5x4, x2 equaling 0, x3 equaling 1 plus 2x4, and we don't know what x4 is yet. To solve that, what we're going to do, and one second, I just got to the page. You know what, I'm actually going to keep it big, because it's a little bit easier. I don't want to let me space this. So, what we're going to do is we're going to take both equations with x4 in it, and we're going to solve. So we have x1 equaling 3 minus 5x4. x1 equaling 3 minus 5x4. And we have x3 equaling 1 plus 2x4. 1, 2x4. There we go. Now, what we do is we solve for x4, for one of them. So, x4, we're going to reverse what we just did. We're going to have a negative, we're going to have x1 minus 3 divided by negative 5. And then we pull, oh, I think I did something wrong here. Oh, I know what I did wrong. Silly me. We don't have to solve for x4. I was wrong. x4 is a parameter, t. And what that essentially means is that x1 becomes 3 minus 5xt. Oh no, 5t. And x3 becomes 1 plus 2t. And what essentially that means is that they have an infinite amount of solutions. Next question. We are now here. Determine each as an equation and graph and interpret solutions to graphing. So right now, we're going to interpret this one right here. x1 plus x2 equaling 4, x1 minus x2 equaling 2. So I'm just going to quickly write that out so I don't lose it. Equaling 4, and x1 minus x2 equaling 2. Okay, I don't know if you know anything about graphing, but essentially what we're going to do is we're going to take one of these and let it be y, which is going to be x2, and we're going to solve for y. So first of all, we're going to say x2 is going to equal 4 minus x1, and x2 is equal to 2. This is negative, divide by negative 2, this is negative 2, and plus x1. Okay, so what I'm going to do is rearrange both these actually. Negative x1 plus 4, x2 is x1 negative 2. Okay, and if you're used to graphing, so what this is essentially y equals mx plus b. And well, like once you bring it there, it's actually quite easy. We're going to take our graph and we're going to go like this real quick. Okay. This makes it very easy. So if this is our y, or our x2, and this is our x, or x1, what we have is a positive 4 point when x1 is 0 for one of the lines. So when this is 0, it's positive f4, or positive, so you go 1, 2, 3, 4. There's the point. At 1, we get at 1, so when x1 is 1 for this equation, right here, we get 3. So at 1 we get 3. So at 1, 3. 1, 2, 3. And if we keep continuing, 2, we'll get 2. At 3, we'll get 1. And at 4, we'll get another 0. And that's our line. There's actually a very fast way of doing that, and I'm going to be doing that quickly. This is easy grade 10 stuff, but if you'd forgotten this, well, there's our line. So that's this line right here. This is our y equaling negative x plus 4. Another line, which is going to be this one right here. And this is essentially just a line. At 2, we're going to have 0, so 1, 2. Here's a point here, negative 2, 1, 2, there, and we create a line. Bam. Where do they intercept? Right here. Now, it's probably not completely accurate. It's probably not on 3 because like my graph isn't exactly amazing, but like essentially that's where it should be. And that's the answer to that one. Very easy. Next is 2x1 minus x2. C. 2x1 minus x2 equals 3. And negative 4x1 plus 2x2, negative 4x1, oops, plus 2x2, I'm pretty sure, is that what I said? Plus 2x2, yeah, equals 6. Okay. Again, we're going to put this in a y equals mx plus b form. You could actually take either one of these and make them y and make either x, but it's whatever. This time I'm going to do this. I'm going to make x2 y again. So x2 negative 3 plus 2x1 and x2 plus 3 plus 2x1. Here, this one, I know that this is this, but I divided everything by 2, and that's how I got all of these. So, they're pretty much the same line, except for, well, they're shifted. So, what's going to actually end up happening, and what you're going to see is they're never going to touch. Like, these two lines are never going to touch, and I'll show you why in a second. I'm pretty sure they're never going to touch, because I'm pretty sure they are parallel. But just to be sure, why not graph it? Okay? If you're unsure, graphing is always good. So, we'll start off with this one. Again, our x2 is our y, and our x1 is here. So, when is this 0? That is 0 at, let me think, negative, let's find out. I can't do it in my head, I apologize. But essentially, if I make this equals 0, what we're going to get is 2x1 negative positive 3 over 2. So x1 is 0 at 3 over 2. So we're going to say if this is 1 and this is 1.5 right here, that's where it's going to be 0. Simple enough. 3 over 2. And then when this is 0, it's going to be negative 3. So 1, 2, 3. And then we draw that line. This is going to be the same thing, except for it's going to be a negative 3 over 2. So on this side, negative 3 over 2, and a positive 3. 1, 2, 3. And again, we make the line, and would you look at that? I was right. Parallel. They never touch each other. They don't have solutions. And that is a good point of graphing. Graphing can be really strong for like visualizing and helping you solve something. Next is, let's take a look real quick, just so I can memorize. Next is solving these two. And these two, what we're going to do is we're going to use actual linear algebra. I'm not going to do back substitution because it takes so long. What I'm going to do is use a matrice. And what a matrice is essentially what you do is you take all these numbers, like here, and you convert it to just the coefficients. You put in a little box like this. A lot of people put the line separator here just to show that these are solutions. And I'm going to show you how to essentially do that. So what I'm going to do is I'm going to bring it to the other page. Actually, I'm going to finish this here because I think I have enough room. Okay. So what we've done is we've taken x1 minus 2x2 equaling 5, 3x1 plus x2 equaling 1, and we've turned it into a matrice. And this is it. Square brackets around, coefficients out front. We've left everything else out. We put the negative here because it's a negative, and everything else is positive, but we don't show it. Okay. So to make this really simple, what we do is we're going to zero out this 3. And how to zero that out? We're going to multiply this whole line by negative 3 and add it to this line. Okay? So, if I do that, if I multiply this by negative 3 and add it, this is going to stay this, by the way, You're keeping it. When you multiply and add, you're only doing it for a second. So, anyways, when I add this to this, negative 3 plus 3, it's going to give me a 0. Okay, that's easy. And what I'm trying to do is I'm trying to reduce it so to only have these 1s out in front. And this one already has a 1, but I need a 0 here and a 1 here. And it's gonna make sense in a sec. So if I want to get rid of, so I have to do it to everything. So I multiply this by negative 3, which is going to give me positive 6, and I add it to 1, and that's a 7. Negative 3 times 15 is negative 15 plus 1, negative 14. Okay, now I want 1s again. Like I said, I want 1, so what I'm going to do is I'm going to divide this whole thing by 7. Okay, and that's going to keep me here. So I'm keeping this line the same, and I'm dividing by 7. Would you look at that? Now, the issue is that I don't want this to have a number, because right now what this is saying is that x1 plus, I should say minus, negative 2x2 equals 5, and x2 equals negative 2. That's what that's saying right now. I still have that 2x2. I want to get rid of it somehow. How do I do that? Well, we go upwards. We're like, you know what? If we can go down, why can't we go up, right? So we multiply this by something to get rid of this here. This 0, I want this to be 0. Well, if I multiply this by 2 and add it, that'll be 0. So in order to do that, I multiply by 2 and get 0, and that's going to be my 0. Awesome. I also have to do it to this coefficient right here. So if I multiply this by 2 and add this, what do I get? Well, 2 times negative 2 is negative 4, plus 5 is 1. And we keep the line the same. Okay? And that is our solution. But, you know what? Some people don't like this solution, not in matrices form, so we bring it back. So we say x1 is equal to 1. Oh, I could have cut the lines in. Sorry about that. Anyways, and x2 is equal to negative 2. Voila! Whoa! And this is why linear algebra is so powerful, because it's capable of solving like so many things so quickly. And like, this is a smaller one, but we're going to use it on a bigger matrix in a second, and you're going to see why it's so much more powerful. And it's this matrix right here. Okay, and this is going to take me a second to write down, so bear with me. I'm actually going to just take it out. Okay, I'm just going to rip it forward. Yeah. Okay. So what we have here is D. x1 plus 2x2 minus x3 equaling 1. 2x1 minus x2 plus x3 equaling 3. Minus x1 plus 2x2 plus 3x3 equaling 7. That's a bigger one. That is a lot bigger than what we've just dealt with, and it's going to take a little bit longer, but hey, you know what? I think we're up to this, right? So what we're going to do, again, is we're going to put it in a matrix form. Negative 1, 1, 2, negative 1, 1, 3. Negative 1, 2, 3, 7. Oof. We can keep the line here. I normally forget about it. I just leave it because, like, as long as you remember, like, the last line is, like, your solutions, you're good. You can do this without solutions as well. That's a whole different thing that I'll be getting to later. But, yes, we can be doing that. So, let's go over this. So, what we have here is we have our 1 here already, which makes things easier because we want it to be 1. So we don't have to move anything, we don't have to do anything, we just have to start getting rid of things. To get rid of this line, what I'm going to do is I'm going to multiply this line by negative 2 and add to it. Okay, so we're going to keep the top the same because that's what we said we'd do. And no matter what, you're going to get a 0 in this because, well, that's what you intend to do. So you don't even really have to think about it, but essentially Negative 2 times 1 plus 2, 0. Negative 2 times 2, negative 4, plus negative 1, negative 5. Negative 2 times negative 1, 2, plus 1, 3. Negative 2 times 1, negative 2, plus 3, 1. I know it's a little bit tedious, but like that's how you have to do it. There's software to do this, but like if you want to do well, you gotta learn it, right? So next is the third line, and I normally do 2 lines at once because that's just the type of person I am. What can we add here to get rid of this 0? Like this number right here, I want to get rid of it. I'm like, you know what? I don't want that. I want a 0 there too. Well, I just add it because 1 plus negative 1 is 0. You don't have to do anything. You just add the lines. So 1 plus negative 1 is 0. 2 plus 2 is 4. Negative 1 plus 3 is 2. 1 plus 7 is 8. Right? Like, is it like, once you start getting this pattern going, you like it starts making it a little bit easier, more simple, you know? Like, you start getting it, it starts clicking in, okay? Now, we have 2 lines here. We have this line and this line, and both these lines are terrible. You want to get rid of them in such a way that this becomes a 1, and what you have to do, if I wanted to make this a 1, I'd have to divide this by negative 5 first, which is going to be 3 over negative 5, 1 over negative 5. Or, like, I'm going to have to do that no matter what, or I could divide by 4. And dividing by 4 is a lot easier, but before you do that, you actually have to switch rows. And I know you don't know the math behind it, but you're allowed to switch rows. I'm not going to tell you that, I'm not going to go through the reasoning, because, yeah, lazy, but you're allowed to switch rows. So we're going to do that. And look at that. We switched the rows. And now that this is here, we can have this as our 1 instead, and we can essentially divide by 4, which is a lot easier and a lot nicer looking. So that's what we're going to do. We're going to divide this one by 4. 1, 2, negative 1, 1, 0, 1, 1 half, and 2. 0, negative 5, 3, 1. See, now the math is a lot easier to deal with, and the reason is because, well, you only have that 1 fraction to deal with, and the half fraction is a lot better than a 5/3 or a negative 5/3, you know? So now we still have to get rid of this number, so why don't we do that right away? What can I multiply to get rid of this? Well, 5. So we're going to keep the top line the same because we haven't touched it. We're going to keep the second line the same because we're not changing it. We're just multiplying and adding it to this line to get rid of it. So this is going to be 0, 0. Except now we have a negative 5 halves plus 3. And if you're not good at fraction math, you just go like this. Okay, so negative 5 halves plus 3. Now, in order to add these together, they have to have the same bottom. In order to do that, you multiply the bottom to the top. So we get negative 5 halves plus 3 halves, which is going to give us negative 2 halves, which is negative 1. Voila, we get negative 1 there. That's a lot simpler. I know, like, fractions scare people, but, like, would you look at that? It came out as not a fraction. Anyways, so we still have to deal with this too, times negative 5, negative 10, plus 1, negative 9. And look, now I don't have to deal with that nasty fraction of 5/3 at all. I'm going to divide this by negative 1 to get me that 1 again, and voila. Now again, this will look like this right now. If you bring it back to the linear equations, equaling 1, x2, plus 1 half x3 equaling 2, and x3 equaling 9. Now, if you wanted to do back substitution, you could. You could take this 9, put it here, solve, put it here, take this, what you solved here, and put it here, and voila, you have it. But again, I prefer the faster route, in my opinion. So what I'm going to do is I'm going to figure out a way to get rid of this 0 and this 0 first, and then I'm going to do that again for that one. So first we're going to start at the bottom. If I want to get rid of that 1/2, I'm actually going to do line 2 first, so I don't waste paper. So if I want to get rid of that 1/2, I have to multiply by negative 1/2. So that's going to be 0 no matter what. But here, again, we have if we multiply negative 9, we're going to get negative 9 over 2 plus 2 equaling something. And again, in order to use fractions, all you have to do is multiply by the denominator and make sure that they have the same denominator. They have to have the same denominator, okay? So what that's going to give you is 9 over 2 plus 4 over 2. Oh, you know what? I made a mistake. I have to correct myself right now. I made a mistake right here. I forgot to multiply this by 2, which is going to give me 6. Okay, so the math isn't that great. That's a negative 1/2. Okay, so I have to correct that real quick. Where did I make that mistake? Negative 1/2 was right here. Right here. Oh. So that's still negative 1. That's still 1/2. I want that to be 1, so what I'm actually going to do is I'm going to multiply this by 2. And that's going to give me 2/18. And for now, we're going to keep it looking like this. Okay, so I've seen my mistake and I corrected it. And I apologize for that. I make mistakes. I'm very much human. Okay, I'm going to move this a little to the right so that I can work on the next one. So I'm going to divide, oh, that should be a 1. Anyways, so I multiplied by 2 and got rid of it, and that's helpful. And that actually makes things a little bit easier for this. So we're going to do this again. What can I multiply this to get this? And that is by 1/2, negative 1/2. And I'm not going to use the top line again, because what we're going to do is we're going to do a few things really quickly. So this should stay the same, and we're multiplying this by 1/2 to get rid of this number and this number. So negative 1/2, this will be 0. Negative 1/2, this will be negative 9, plus 2, negative 7. And then here, we want to get rid of this, and to get rid of this, we just add it. So 0, 18, 1 plus negative 1 is 0, and 18 plus 1 is 19. Would you look at that? And now we just have this one spot to get rid of. Okay? And I'm going to actually leave this the same and do it in one more step here. So what I'm going to do is I'm going to multiply this by negative 2, this line by negative 2, and add it to this top line. So this will be 0 again because, well, that's the intention, is to get rid of it. So this just becomes automatically 0. This is already 0. And this is negative 2 times negative 7. Is that a 14 or 19? 19. That's a 19. Okay, so 14 plus 19, that is going to be 35, I believe. No, 14 plus 19, 33. 0107 00118. Would you look at that? Now this says x1 equals 33, x2 is 7, and x3 is 18. And there are solutions.
Bam.
Okay. Now, that is lesson task 1. I'm quickly going to go set up a lesson task 2 questions for ourselves to work through and continue. So we're going to take a quick intermission. And we're back. Alright, so now we're going to go over task 2, which is like chapter 2 for linear algebra. And we're going to go through these questions quickly. Okay, so first off, what we're going to do is essentially for question 3, it has been reduced to row echelon form, and I know you don't know what that is, but essentially what we've been doing is reducing everything to row echelon form, where the zeros, it's where there's a bunch of zeros and we have the leading ones, and these are called leading ones, so like they lead downwards sort of thing, and like that gives you the solutions, and that's called row reduced echelon form, because what we're doing is reducing it into a solution. So what I had shown you is a little bit advanced for what was before, but essentially it's the same thing. Now, what this question is asking for is essentially just find all the solutions. Okay, well, for the first one, what we have is 1, 0, 0, negative 2, 5, 3, 0, 1, 0, and 0, 0, 1, 3. Okay. If you've been following me, you'd know that, well, this is a little bit easy, because essentially in this form, all this is x1, which is this one, plus 0x2 plus 0x3 equals negative 2. So for this line right here, that's what this equals, and essentially x1 equals, oh, sorry, I didn't mean to put that 2 there, x1 equals negative 2. And if you follow that trend, for this one, 1x2 must equal 5, and x3 must equal 3. And that's it. That's the solutions for this. If this is our x3, this is our x2, and this is our x1, and they correspond to this, well, there's our solutions. Now, let's try a little bit more complicated one, but essentially, same process. We get this. This has been row reduced as well. Okay, so we have some issues here. Now, row reduced, like, if they say it's row reduced, it means that it's the most, it's like, this is as far as it can go, right? Well, what this implies is that x1 plus negative 3x2 equals negative 2. Okay, and x3 equals negative 2. Well, what do we do about that? I'm going to make this a little bit neater for you quickly. Well, like, what do we do about that? It's kind of weird to imagine. How do you find the solutions for this one? You can't do anything, right? Like, you can't move this here because there's no x3 up here. Well, this is where we say, hey, what if we make x2 equal t? We say it's a parameter. We call it a parameter, something that can be anything essentially. Like x2 can be anything. Okay, it can be any number. It could be 5. It could be 12. It could be literally anything. All right. Well, if that's the case, then x1 minus 3t, because we put it there, equals negative 2. All right. Well, then that means x1, if we add positive 3t to both sides, we'll get negative 2 plus 3t. And there's our answer right there. It essentially means, what this means is that there is an infinite amount of solutions for x2 and x1. As long as t is something, you're always going to have a solution for x1, which is always going to be a solution for this. And there we have it. So t is a parameter, and that's it. And there's our solution. Wow. Fairly simple. And then we have this big monstrosity, e. We're like, whoa, what the hell is that? Like, that's huge. What am I going to do with it? Like, even writing out, I'm just getting tired, you know? Like, what the frick? Well, that's a lot of frickin' zeros, that's for sure. we're going to put that line there to know that this is solutions, blah, 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 blah. Okay, pencil. So, again, well, all these zeros mean that zeros are zeros. You don't even have to look at that, essentially. We go bottom to top because it's a little bit easier that way, because look at this. We have one thing equaling something, which makes things easier. At least we know. And if we say this is x1, x2, x3, x4, well, x4 must equal 6. Whoa! Well, we got one thing out of the way, but that top line kind of looks tricky, right? Right now what we have is x1 plus 5x2 minus 2x3 equaling 3. Ooh, that's ugly. You're like, well, how do I do this then? Like, if we look at the top here, what? We only had the one line. Well, you know what? You know what you can do? And you can do this, is say, why not make x2 equal s and x3 equal t? We just add 2 parameters. We're like, you know what? Screw it. Screw it. We're going to give it 2 parameters. So we're going to give it 2 parameters. Alright, well, if that's the case, then we have x1 plus, we're going to replace x2 by s, so 5s minus 2t equaling 3. And look at that. x1 is going to equal 3 plus 2t minus 5s. And essentially what that's saying is that t and s could literally be any number. 2 of them can be any number, infinitely. And x1 is going to solve the solution. And that's the case for this, because whatever you put into t and s, it's going to solve whatever this was originally. It has infinitely many solutions. And yeah, that's it. And you're like, okay, look, that wasn't as hard as we thought. Okay, next. This is asking for consistency and to solve. So it's going to ask if you want consistency, and if it has consistency, solve it. What essentially consistency is if I have a matrix C and we say 0, 2, 0, 0, 1, and we have solutions, this is an inconsistent system, and the reason it's inconsistent is literally this line. You can't have 0 equaling 1. There's nothing. It's not a solution. You can't have something. If this is a 2, a 3, you can't have 0 equaling something. You know, like that doesn't make any sense. Therefore, it's inconsistent. And I've selected these examples specifically, but I don't know if they're consistent or not. We're gonna find out. It's a simple test. We just say if this equals something, inconsistent. If it does, if there is something that's like it equals, like x2 equaling 2, well then it's consistent, you know? So, okay, so here we go. B5, B, 2x1 minus 2x2 equaling, 2x1 minus 3x2, sorry, equaling 5. Minus 4x1 plus 6x2 equaling 8. Now they say to use back substitution, but what I'm doing is I use Gaussian elimination, and Gaussian elimination is that process before where we go through each row and reduce to 0. And I actually use Gauss-Jordan elimination, which is a combination of Gauss elimination, but you go upwards as well. So what we get is 2 minus 3 5, negative 4, 6, 8. Now again, you can have this line if you want to show that, hey, these are solutions, but as long as you remember, you don't have to, and I'm not going to because lazy. So, now, between these two lines, we have an issue. We can divide by 2 and get the negative 3 over 2 and 5 over 2. Or, we can divide by negative 4. And get a nice number. It's up to you. I personally want the nice number. So what I'm going to do is I'm going to switch these rows around to make it look a little neater. So negative 4, 6, 8, 2, negative 3, 5. And then divide by 2. Negative 2. Or negative 4 to get that one out. So 1, negative 3 half, and negative 2. Right? This should make sense because negative 4 divided itself, 1. Negative 6 divided by 4 is going to give you negative 6 over 4. You can divide that by, well, 2, so you get negative 3 over 2, which is right here. And negative 8 divided by negative 4 is negative 2. That's simple. I want to get rid of this 2, so how do I do that? Well, what I can do is I can multiply this by negative 2 and add it. And then what I do is I do that to all this, right? So I add this whole line downward by multiplying by negative 2. So again, what we're going to end up with is that 0 right away. Negative 3 times negative 2 is, well, 3 plus 3. It's going to give me 0. And negative 2 times negative 2 is 4 plus 5, which is 9. And would you look at that? We just talked about inconsistent systems, and look what we have already. 0. Is the system consistent? No. I can't do anything to get rid of this, and this, if I divide it by 9, it'll still give me 1, right? So no matter what, this system is inconsistent. Inconsistent. It's a bad baby. Bad baby boy. Bye-bye, inconsistent system. And if it's inconsistent, you're done. There's nothing else you can do. There's no way to solve it. Bye. We move on with our lives. Okay, we're going to use C now. Ooh, she looks big. Now, you have to be careful with your X1s and X2s because they're going to play some tricky-dicky games with you sometimes where they put like X1 and X3 beside each other, and if you're not paying attention, you're going to get it wrong. But you know what? We're not going to get it wrong. Why? Because they are together, so we're fine. Whatever. Okay, so we wanted to get rid of all this, so let's go like this. 1, 1, 0. 2, 3, 0. 3, negative 2, 0. I know what you're thinking, and there's a bunch of zeros at the end. Chances are you're going to get 0 as all the answers. Well, yeah. That's pretty much what's going to happen, isn't it? You're going to have x1 equaling 0 and x2 equaling 0, and the only way to have 0 is if it all equals 0. But just to make sure, we're going to go through the math, because there's nothing you can multiply. So yeah, it's the only solution is 0. But again, let's go through this. So to get rid of that 2, I multiply by negative 2, this line, and add. So what we're going to end up with is 1, 1, 0, negative 2, 0, negative 2, plus 3, 1, 0, and I'm actually going to do this line as well with this line because I don't want to rewrite everything all the time. So what can I multiply this or this to get this equaling 0 by adding? Negative 3 plus 3, 0. Negative 3 plus negative 2, negative 5, 0. Now, would you look at that? If I divide this by negative 5, I'm going to get negative 1. Or 1, sorry. And I'm going to subtract all of these to get 0. So what you're going to end up with 0, 0, 0, 0, 0, 0, 1, 0. And look at that. x1 equals 0, x2 equals 0. Who knew? Too easy, bros. We just went through it because, like, why not? And H. We're going to have x1 minus 2x2 equaling 3. 2x1 plus x2 equaling 1. negative 5x1 plus 8x2 equaling 4. This looks a little bit more fun, like it won't take us like a half a second to finish. So we're going to put this in our matrix. 1, negative 2, 3, 2, 1, 1, negative 5, 8, 4. And we're going to do Gaussian elimination, which is the process I've been showing you this whole time. Why? Because it's my favorite. It's the fastest way in my opinion. So, I want to get rid of this line and I want to get rid of this line. To get rid of this line, I just multiply by negative 2. So we're going to keep that up top real quick. Negative 2, 0 times negative 2, 4 plus 1, 5. Negative 2 times 3, negative 6 plus 1, negative 5. To get rid of this, we just multiply by 5. So 5 plus this, right? So negative 2 times 5 plus 8 is negative 10 plus 8, negative 2. Negative 5 times, or no, 5 times 3, 15, plus 4, 19. I don't like that 19, but hopefully doing some more math is going to solve that for us. So, what I'm going to do is divide this by 1. Or not 1, 5 to get 1 and negative 1. And then I'm going to add this to this, essentially. I'm doing 2 steps at once here, so if you get lost, you can just say something, but nobody's there watching anyway, so it doesn't even matter. Okay. To get rid of that negative 2, though, we multiply this by 2, and we add it. So, would you look at that? 2, 0. And 2 times negative 5 is 10, which is going to give us 9. Oh, look, would you look at that? The system is inconsistent. Bye-bye. Well, if it's inconsistent, we don't need it. We throw it away. We're done. We're out of here. Alright. And we're going to do question 6 of this textbook that I have, that you don't know. And we're going to solve this. Now, I'm pretty sure this won't have any inconsistent systems because it literally just says solve. And if it says solve, well, chances are it's going to be consistent. So, I'm going to move on. Let's see, 6. x1 plus 3x2 plus x3 plus x4 equals 3. 2x1 minus 2x2 plus x3 plus 2x4 equaling 8. 3x1 plus x2 plus 2x3 minus x4 equaling negative 1. Alright, so let's put this in our matrix. Let's turn it into a matrix. 1, 3, 1, 1, 3, 2, negative 2, 1, 2, 8, 3, 1, 2, negative 1, negative 1. And we separate by our solutions, but I'm actually going to not keep that line. Because you know me, just lazy. You can put the line in whenever you want, but you don't have to. So, this looks nice because I have that 1 right here, so I'm actually just going to keep it, and we're going to go down. So, how can I get rid of the next line? To get rid of this next line, I just multiply by negative 2, and then add everything. So, multiply by negative 2, add negative 2 times 1, plus 2, 0. Negative 2 times 3, negative 6, plus negative 2, negative 8. Negative 2 times 1, plus 1, negative 1. Negative 2 times 1 is negative 2, plus 2, 0. And negative 2 times 6, or negative 2 times 3 is negative 6, plus 8 is 2. And then I'm going to do the same thing for this line, except for it's going to be negative 3. So times negative 3. So negative 3 is 0. Negative 3 times 3, 9, negative 9, plus 1, negative 8. Negative 3 times 1, negative 3 plus 2, negative 1. Negative 3 times 1, negative 3 plus negative 1, negative 4. Negative 3 times 3, negative 9 plus negative 1, negative 10. Okay. Now we have two lines here, all with negative 8 in the front. What I'm going to do is I am going to do something, because these are the same lines, and if I divide by negative 8, then I'm going to get 1 over 8, negative 8. Okay, I'm going to switch these rows, and I'm not going to divide by negative 8. And this is why, and I know what you're thinking, you're like, but why not? Well, I don't actually have to do that right away. What I can do is just add two lines together by multiplying by negative 1. And you'll see what happens. If I multiply this by negative 1 and add it, I'm going to end up with this. 0, 0, 0, 4, and what's this? Negative 110 plus 2, 12. And would you look at that? That looks so much nicer. And before I row reduce this, and again by dividing, what I'm actually going to do is I'm going to divide this by, actually I am going to do it now. 1, 3, 1, 1, 3, 0, 1, 1 over 8, 2 over 8, which is 1 over 4. Alright, no. It's 1/2. And negative, or 10 over 8, which is divided by 2, 5/4. 0, 0, 0, and I'm actually going to divide this line by 4, which is going to give me 1 and 3. Now this looks pretty gross. This is all those, oh, sorry. This looks pretty gross because there's all those fractions in there still. But we must press on. What I'm going to do is I'm going to get rid of this and this next. And first we're going to get rid of this by multiplying by 1/2, negative 1/2. So we're actually going to keep the bottom the same because, yep. So we're going to get rid of that 1/2 first, which is going to be 0, but I have to multiply by a negative 3/2, or negative 1/2. So this becomes negative 3/2 plus 5/4. Fourths. I know we don't like our fractions, but life sucks. Okay. In order to add these together, they have to have the same denominator. Well, that's a little bit easy. We just multiply this whole thing by 2. Which is going to give us 5/4 minus 6/4, which is negative 1/4. And bam, we have what we came for. And then we just want to get rid of this. Well, we just multiply by negative 1 to get rid of that. So, bam, bam. Would you look at that? Now, I also want to get rid of this, and in order to do that, I have to multiply by 8. I'm going to separate that 3, just a little bit more. So, just to show you what's happening, 0, 0, 1, 3. I'm wanting to get rid of this one, so I multiply this whole line by 8 and add upward. Oh, actually, ooh. No, I have a leading one right here. I didn't even see it. It's a good thing I double checked. That's not what's happening at all. I want to get rid of this number here. So in order to do that, I add this upward. So 1 times negative 3 is going to give me that 0. So negative 3/8 is going to be right here. Oh, 1 minus 3/8. And this is actually going to be positive 3/4, because negative times a negative. And we just have to solve for this one, which is 1 minus 3/8. So we multiply this by 8 to get 8 over 8 minus 3 over 8, which is going to give me 5/8. Okay, and that is reduced as much as it can be. You can't get rid of this because, well, there's not enough solutions to give it. So essentially what this is saying is we have x1 plus 5/8 x3 equaling 3/4. x2 plus 1/8 x3 equaling negative 1/4, and x4 equaling 3. Again, this is reduced as much as it can be. We need something to give us solutions for x1 and x2. Well, what if we make x3 a parameter and we say it's equal to some variable t or s or x, whatever letter you decide in the alphabet? Well, then that would make x1 equaling, or no, actually, that would make this equation, if we plug it back in, x1 plus 5/8 x, oh no, sorry, 5/8 t equaling 3/4, and x2 plus 1/8 t equaling negative 1/4. And then we just solve for the solution. So we get this, 3/4 minus 5/8 t, and x2 equaling negative 1/4 minus 1/8 t. Bam! Those are our solutions right there, and x4 is still 3. So here is our solutions for this. And what this says is that there's an infinite amount of solutions for x1 and x2. But x4 will always equal 3. And yeah, that's 6 for you. Now, this last question is a consider question, and that's what makes it a little bit more difficult. So if it takes me a second to solve, I apologize, but yeah. So we have 10, and it says consider 1, 1, 3, 2, 1, 2, 4, 3, and 1, 3, A, B. So first we consider, and we're like, would you look at that? I consider that to be a matrice, and I consider that to have numbers, but what does that A and B do in it? Yeah, consider. Okay. And then it asks the questions. A. What do A and B have to be to have infinite solutions? What do A and B have to be to have infinite solutions? Well, what that's saying is that if B is just a solution, then A is a coefficient of x3, because what this line is saying is essentially we make this x1, x2, x3, and B. What we're having is 1x1 plus 3x2 plus ax3 equaling B. And they want to know what this coefficient is and this solution is, so that it has infinite amount of solutions. And in order to do that, in order to find that, what we're going to do is we need to find a parameter, like in the previous question that we just did, where something is equal to t. And to do that, we have to solve. So first things first, let's solve this mofo. And again, we're going to row reduce echelon form, or row reduce Gauss-Jordan elimination. That's what we've been doing this whole time. So if I were to do that, which I am, we're going to take this and we're going to be like 1, 1, 3, 2. 1, 2, 4, 3. 1, 3, A, B. We have the solutions. I'm going to get rid of that line in a sec because I fucking hate it. Excuse my language. But if you're doing this, you're probably old enough to get a little letter language, you know? Just the thought. Anyways, so to get rid of those ones, I multiply this by negative 1. We're going to keep that. Negative 1 and add. So negative 1 times 1 0. Negative 1 plus 2, 1. Negative 3 plus 4, 1. Negative 2 plus 3, 1. And then we'll do it again to this one. Negative 1 times 1 plus 1, 0. Negative 1 times 1 plus 3, 2. Negative 3, 1 times 3, negative 3 plus a. Oh, this is where it's going to get tricky dicky. And you got to be careful. So negative 1 times 3 plus a. So a minus 3. Negative 1 times 2 plus b. Or b, I'm going to write it like this. Okay, that got a little bit more complicated. I'm going to keep that line in, actually. Yep, that got a little bit more complicated because now, look at what we have. We have... Oh, what did I do here? This is gone. There we go. Yes, okay. 2, 3... Something's wrong here. There should have been a 2 and a 1. Yes, okay, sorry. My mistake, my mistake. Anyways, so now we have these. And that's a little bit like, uh-oh, spaghetti-o. But that's okay. We press on. Now, I want to get rid of this too. Well, we just keep going, you know? We keep running this life. We multiply this by negative 2, this whole line, and we add. So, again, we're going to keep this line up here. This is going to become 0 because negative 2 times 1 plus 2 is 0. Negative 2 plus this is going to be a negative 5. Negative 2 plus this is b negative 4. And what's happening is I'm adding it to the totals, right? Because negative 3 plus negative 2 is going to be negative 5. Negative 2 plus negative 2 is going to be negative 4. Okay, okay. Well, Jordan elimination requires that I somehow get a 0 out of these two. That's somewhat difficult. Like, how am I going to get a 0 out of that? Well, I have to make it equal 1. And this is a little bit complicated, but like, if I divide this by a minus 5 on both sides, and then, oh, I should say negative a minus 5 to get that negative, and then I add, it's going to become 0. And in fact, actually, before I even do that, I want a 1. So, you know what? I'm going to go like this. 1, 1, 3, 2, 0, 1, 1, 1, 0. And I'm going to divide this by a minus 5. So a minus 5 over a minus 5 is going to give me that 1. And b minus 4 over a minus 5 is going to be in that column. And look at that. We have our 1. We have our 1s now, you know? It's freaking crazy. This means that x3 is equal to this, but hey, that is perfect. That's what we're looking for. We want a parameter, and like, this is how we're going to get our parameter. So we're going to multiply this by negative 1 and add upwards. So what this is going to look like is 1, 1. I'm going to leave that open for a second. 0, 1. Negative 1, so 0, 0, 0, 1, and we're going to multiply this by negative 1 to this. So negative 1 is going to be 1 minus b minus 4 over a minus 5. I'm actually going to change this real quick to make it look a little bit neater so that we have it all in one line. I don't think I need the double brackets, actually. I do need it around this, though. B minus 4, A minus 5. And then we got to do, for up here, we got 3, so we got to multiply by negative 3. And that's going to be 0. This is going to be 2 minus 3, B minus 4 over A minus 5. I know, that looks pretty complicated. And then, when you look at that, I need to put this. That looks complicated. Yep, that looks complicated. Sorry, I didn't realize I was not writing. Nobody's watching anyway, so it doesn't matter, but anyways, to get rid of this, I multiply by -1 and then add. And to do that, I have to do that with this as well. So what we're going to end up with is 0, 0, 0, 2 minus 3, b minus 4, a minus 5, minus 1 minus b minus 4, 0, 1, 0, would you look at that? That looks atrocious. Okay, so in order to parameterize this, we need to end up with one variable, just one. And we can't let a equal 5, because if a equals 5 for any of this, this all becomes hoopla. So a cannot equal 5. So what we have is x3 equaling b minus 4 over a minus 5. x2 equaling 1 minus b minus 4, a equal 5. And x3 equaling 2 minus, now these have the same bottom, so this is actually, well actually I'm going to do this first, for a minus 5 minus 1 plus b minus 4, a minus 5. So this will cancel out, and this will give us just 1 minus 2b minus 4, a minus 5. Now, I know you haven't picked up on it yet, but essentially what this is saying is we already have our parameters for everything. A and b could be any real number except 5, and we would have solutions. A and b are parameters. I know that's crazy to think about, but essentially a and b can be all real numbers except a cannot equal 5. And that will give us instant solutions. What? There is one more question for that, and that's b. What values do a and b have to be for an inconsistent system? What values do a and b have to be for an inconsistent system? Okay. Now, if you remember what an inconsistent system is, essentially it's 0, 0, 0, 0, 1, where there's a solution when there shouldn't be, essentially. And we have to figure out what a and b have to be. So where x3 is equal to 0, but a and b are not equal to 0. So that b minus, what was it? B minus 4, a minus 5 equals something. And the easiest way to show that, let me think for a second. The easiest way to show that Maybe I'm thinking that you actually don't have to show that. What you have to say is that it's when a equals 5. And that's because this will give you well, not a 0, but essentially everything else will give you an answer, but when a is equal to 5, you won't get that answer. You won't get a answer. So it's inconsistent when a equals 5. Alright. And now that we're done that section, I have one more section to go through, and then I will end. Actually, I am going to end because I have dinner to attend to for my girlfriend's birthday, and yeah, so I'm going to end it now. Have a good day, guys, and enjoy watching this, or I hope you enjoyed watching this or learned something.